Once again, my name is Hendrik Makaneta, and we are going to start with our grade 7 lesson, mathematics. We have already started with our topic, patterns being the very first topic of the term. And so far, we have done a lot of examples, and we have also looked at the different rules. And today, we will take the topic to the next level by looking at, amongst others, the tables, just like the table that I have in this instance. Please study the table, and in particular the pattern in this table, so that we can be able to answer the questions that will follow. So you can see that in our table here, we have a position. We also have the term. So the position 1 there, position 2, 3, 4, 5, and then we have got an unknown position there, followed by 10 and then 15. So this is a position which also moves in the form of a pattern from 1 up to 15. And of course, the term 1 there, in position 1, the term that we have is 12, and in position 2, we have the term there, 22, and in position 3, we have 32, and so on and so forth. In position 4, you can see that we have 42. In position 5, we do not have any term there. There's a question mark, and in position 82, I mean the next position there, it's unknown, but the term is 82. And the next position is 10, the term is unknown, and the position 15 as well, the term is not known. So what we need to do is to use our knowledge that we've gained up to so far, the rule, to find the missing values in this table. And I believe that you will be able to do exactly that, to find the missing positions in this case. And you are welcome to, at any time, use the group chat. And of course, you can also use the voice, your mic as such, just to answer the question. So I'm going to zoom directly into the first one, just to carry on to show you how do we find the missing values. Like I said, we have already spoken about the different ways of finding the next 3 terms. We've done that already yesterday and the day before yesterday. Today, we are focusing on the bigger picture now. We are looking at the table, and of course, the same principle still applies. I want you to check the term and make a conclusion what the rule is. If you look at the position 1, we have term the 12. Position 2, we have 22, and position 3, we have 32. And of course, position that follows is position 4. We have 42 in that instance. So you can already see that we actually have a pattern even in the term block, or in the, yes, in the term block there we have got a pattern. If you are moving from 12 to 22, you can see that there's a number that has been added there, or the constant difference rather. 12 plus 10, if you add 10 there, you will get 22. And then from 22 to 32, again, you will be able to add 10. Excuse me, you'll be able to add 10 there. And again, from 32 to 42, you also add 10. So you can see that 10 seems to be the rule, plus 10. So the rule in the next column there, or in the next row, in fact, the term row, the rule there is plus 10. But now it will be easier if you find the next term. I think that if I were to ask you what will be the term here, the term that is corresponding with position 5, what is that term? What will be the number?
52.
52, exactly. So it will be 52 because it's position 5. So you are adding 10 to 42 to get 52. So it will be 52. Now, if you look at the next one here, we have actually skipped a few. From 52, you can see we are now proceeding to 82. Now, I need to know what will be the corresponding position for 82, for term 82.
8.
So it will be 8. How do you know it's 8?
So because to get from 52, so you're gonna have to calculate so 4 times, and when you add 5 plus 4, so you get 8.
Exactly. So 8 will be the position, and then of course the constant difference. But there's another way of doing this. I'm just going to share it with you now. Now that we have what we call the constant difference in the term, which is 10. So there's a way of finding the rule where you take the constant difference and multiply it with the position, and then you add a number. For example, the constant difference in this case is 10. So if you multiply 10 by 1, you get 10. And then to get to 12, you need to add 2 to that 10. I don't know if it makes sense. It will be the constant difference, which is 10, and then you multiply 10 by 1. By the way, you can take any position. You can even choose 4 or 5. So I've just chosen 1 in this case. If you take 10 and multiply it by 1, you get 10. And then to get to 12, because the corresponding output there is 12, then it means you must add 2. All right. So the same goes for this particular instance, something called the rule. So our rule will be much more helpful to find bigger numbers. If I were to say for you, find the position or find the term in position 100, for instance, you should be able to use that rule. But before we can carry on, you have found 8 here. Now the next one is 10. What would be the corresponding term for position 10? Given that our rule now, we have the constant difference of 10.
It's 102.
102. How do you get 102?
That because you have to add 20 you have to add 2 to get to 8 to 10, and you have to add 20 to get from 82 to 102. So.
Okay, right. So I'm happy you have used that method. So I will come back to the method, or let me rather say the different approach, or the other way is to know that your constant difference is 10. So you take that 10 and then you multiply it by 10 here. All right. You take the constant difference, which is 10, and you times it by 10. So 10 times 10 is 100. And then to get to the term there, you have to plus 2. So it will be 100 plus 2, which is 102. Does it make sense? I hope that it does. We'll elaborate more on it. We still have a lot of examples. And then you do the same with 15. You will multiply, you will take the constant difference, which is 10, and then you times it by 15. So 10 times 15 is 150. And then you add 2 plus 2 there, then it's 152. Just as we demonstrate, you can see that what is important, of course, is for us to fill in those numbers. So the missing numbers in this case will be it will be 52 in this case, which we have already found, and then this one is 8, and then 102 and 152. I hope that everyone is able to calculate this. I just don't want to rush you. I just want to make sure that everyone is on board. What I've said now is that there are 2 ways in which you can find the next term. The first you need to find the constant difference. What is the constant difference there? And then you take the constant difference and multiply it with the position, and then you add a missing number there. For instance, in this case, where to get 32, you take the constant difference, which is 10. Remember, from 12 to 22 is 10. From 22 to 32 is 10. So you take that 10, you multiply it by 3. 10 times 3 is 30. And then 30 plus 2 will give you 32. For 4, again, you do the same. 10 times 4 is 40. And 40 plus 2 is 42. So 10 times 5 here is 50 plus 2 is 52. 10 times 8 is 80 plus 2 is 82. I hope that you can see the pattern. 10 times 10 is 100, and 100 plus 2 is 102. And the last one, 10 times 15, it's 150, and 150 plus 2 is 152. So this is what we mean when we talk about the patterns. Perhaps let's zoom directly into the next one here. I want us to work out the pattern in the table below, and thereafter fill in the missing numbers. Let's check that the pattern has also a constant difference between the terms. So we do have a constant difference. Now remember, you can view the position as an input value there, and you can view the term as the output. So what we need is to find the constant difference in the output, meaning in the terms there. Is there anyone who can tell me what is the constant difference in our terms? All right, I see Fiso Gumbi. I've recognized that Fiso is struggling with his audio. If possible, please just put a message on the group chat if you can. That will be nice as well. If you have any question, perhaps, and this goes for everyone who is unable to speak via the audio. Right now, I want us to look at the constant difference. What is the constant difference in this case, in the term? Meaning that we have the term there, 4, followed by 9, followed by 14. You can see this is a sequence because position is 1, 2, and 3. From position 3, you skip now position 4 up to 9. You skip that, you go to position 10. From position 10, you move directly to position 45. So this is rather different. That's why I said we are now taking the patterns to the next level. Now, can you tell me what is the constant difference in this case? Do we have any constant difference in our terms? How do we find the constant difference? Yesterday, I spoke about the constant difference. I think I think there was a learner who asked a question regarding the constant difference between the terms. And I said, you simply subtract the previous term from the next term. So in this case, we have 4, 9, and 14. So how do we find the constant difference? So I'll just carry on. In other words, you'll subtract 4 from 9. So if you 9 minus 4, then you have that gives you the difference between the two. And then also 14 minus 9. So you can see that if from 9, if you subtract 4, you'll be left with 5. And again, 14 minus 9 gives you 5. So the constant difference is 5. So you can see that the constant difference is 5, and then you can use the constant difference to find the missing terms. And how are we going to use the constant difference to find 5? The constant difference is 5, and of course this goes to everyone. Thank you, Junior. I can see that. I wanted to put the message to everyone. So the constant difference is now 5. So we need to now use the constant difference just to find, or rather to find the missing terms. So I've just put it there on the chat group. Take note of the constant difference. We are now going to use it. How do we use the constant difference to find the missing term? Let's go to position 10. You can see that position 10 there, we have a missing value. What will be the value of this term here corresponding to position 10? And how do you find it? Is there anyone who wants to attempt? Right.
So is it 30?
Okay. All right. So you're asking me if it's 30. All right. Just tell me, how did you find the 30? Did you just take a guess, or did you work it out?
So I multiplied the digits. I need to get from the digit from 3 to 5, so it was 6. So I multiplied 5 by 6, and I got 30. So
Also, you multiplied 5 by 6 to get 30. All right. Let me take you back to the formula, the method that I was just talking about in the previous table. To say, before we go to position 10, maybe let's start with position 1 so that it can be easier for you. All right. I'm going to start with position 1. I have just said that the constant difference is 5. So 9 minus 4 is 5. 14 minus 9 is 5. So I've put in the constant difference. It's very important that we use the constant difference. Now, we are going to take the constant difference and multiply it with the position. It can be any position, either position 1 or 2 or 3, any one of those. Let's choose any. All right, maybe let's take 1 then. So the constant difference multiplied by position 1. So this will be 5 times 1. And what is 5 times 1? 5 times 1 is 5. All right, I'm sure we all agree that 5 times or 5 multiplied by 1 gives us 5. And now we have just multiplied by position 1, but what is the corresponding value there in position 1? The corresponding value in position 1, or the corresponding term value there, is 4. So if you have 5 now we have said 5 times 1 is 5. If you have 5 and you want to be left with a 4, what do you do to that 5? It means you are going to subtract 1. So 5 minus 1 will be 4. I'm sure you all agree with me there. Now, it means that our pattern, or rather our rule, will be you multiply the position by 5 and thereafter subtract 1. That will be the rule. So now we are determining the rule on a different scale now, unlike yesterday. Now the rule will be 5 multiplied by the position, then you subtract 1. I'm sure that it makes sense. If you want to test it for 9, again, you are going to take 5 multiplied by 2. And what is 5 times 2? 5 times 2 is 10. And 10 minus 1 gives us 9. Can you see that? Then for position 3, 5 times 3 is 15. And 15 minus 1 gives us 14. Can you see that? So it means this is the correct rule that we are now applying. So you can actually apply it across the board. So in order to get the term corresponding to position 10, you are going to use the same rule. The constant difference is 5, then you will multiply 5 by 10. And what is 5 times 10? 5 multiplied by 10 is 50. And then remember the rule says you subtract 1. So it will be 50 minus 1, which is 49. So in other words, our term here will be 49. That will be the term that corresponds with 10, position 10 rather. And then you do the same with position 45. You multiply it by the constant difference, which is 5. So 45 times 5 will definitely give you 225. And then 225 minus 1, you will be left with 224. We'll come to that. For now, I'm still showing you just by inspection. And then the last one, you are given 474, and then you need to know what the term will be in this case. So it means that the previous one there, you have actually subtracted 1 from 475. So because 475 minus 1 is 474. So if you divide this 475 by 5, you should be able to get the position number, just as reflected in the next slide. So as I've said to you, the first thing here, we need to write down the rule to find the term given its position in the sequence. And then thereafter, you must use the rule to find the 10th and the 45th term. And C, you must just work out the position of the term that is equal to 474. So I hope that you can see the steps that I'm talking about. The first one is that you need to write down the rule. And we're still going to write down the rule, by the way. I'm still going to show it to you. But right now, I've already given you a hint of how to find the rule. And the first thing, you find the constant difference in the term or in the terms that are given there, 4, 9, and 14. You have to firstly find the constant difference. And how do you find the constant difference? You simply take the previous term and subtract that from the next term. So 9 minus 4 is 5. Or you can say it's plus 5. 4 plus 5 is 9. 9 plus 5 is 14. So therefore, the constant difference there is 5. And then it means you have answered A. So, but now to find the rule, remember, you don't just find the constant difference, you also have to write down the rule, which you can use to, given the different positions in the sequence. So the rule is as follows. You take the 5, which is the constant difference, and you multiply that with the position. And then you subtract 1. How do we know? We have tested it. You test it first. You can't just assume. You need to test it. We have already tested it with 1. We have tested it with 2, and we have done it also with 3. Because 5 is the constant difference. If you multiply 3 by 5, you get 15. And then if you have 15, now how do you get to 14? It means you need to subtract now 1. So 15 minus 1 will give you 14. So that on its own will be the constant difference, or rather the rule that you are going to use. So you can see as we reflect or as we close this question that I've said here, the solutions are as follows. 9 minus 4 is 5. 14 minus 9 gives us 5 as well. So this is the constant difference. So the constant difference, as you can see there, is 5. So what do you do after getting the constant difference? So multiply the input by the constant difference and add or subtract a number in order to get the output. Example, we've taken 1 here as a position. The constant difference is 5. So you take the constant difference and you multiply it with the input. The input is 1. So 5 times 1 gives us 5. Now to get to 4, remember the output value that corresponds with 1 is 4. In other words, the term there that is closely associated with 1 is 4. So to get to 4, obviously you'll need to subtract 1 from the answer that you got. So 5 minus 1 is 4. So that's how you get the 4 there. And then for the second one again, it will be 5 times 2. And 5 times 2, as we know, is 10. And then to get to 9, you subtract 1. So 10 minus 1 is 9. I hope that you can see this rule. And that is why we have decided that we are going to use this rule to now find the missing values. Before I can wrap it up, show me or tell me, how are we going to find this particular activity there? Just to show you, or before we can carry on, I just wanted somebody to tell me, how do we find the term that corresponds with 10 as a position? Can we just find it there before I can just finalize it for you? Just to show you how we have found it. Is if there's anyone who's willing to share with us, but let me just rather go. So in position 10, as you can see, if in position 10, what you need to do is to realize that again, you multiply the position by the constant difference, which is 5. So 5 times 10 is 50. And to get the output, as we know by now, you have to subtract 1. So 50 minus 1 is 49. So in other words, 49 will be the answer there. And then to get the next term there, which corresponds with 45, you do the same. Your constant difference is 5, and then you take 5 and multiply it by 45. So 5 times 45, as I said earlier, is 225. And then 225 minus 1 gives you 224. So the answer here will be 224. And then the next one, of course, is just to find the position. And to find the position, all that you need to do again, you use the same rule. The output, now in this case, we have the output, which is 474, it's given. But now we don't know the input or the position number now. To get the position, you can name it X. I've named the position here X because we do not know the value yet. So it means you are going to take the same constant difference, you multiply it with the position, which is now unknown. So it will be 5 multiplied by the unknown position there, which is X. And then 5 times X is 5X. And as you know, the rule is that you need to subtract 1 from the product. So 5X minus 1 will give us 474. And thereafter, you simply solve for X. 5X will be equal to, you now transpose the -1 from the left-hand side to the right-hand side. It will change the sign. It will be positive. So 474 plus 1 is 475. Now at this point, you can just divide both sides by 5. Remember that whatever you do in the left-hand side should also be done in the right-hand side. So you are now going to divide 475 by 5. So to get 95. So in other words, the position there will be 95. I hope that it makes sense. I don't see any hands yet. I hope that, because this was the next activity where we find missing values. Why do we use this rule? This rule has to be used because it can help us to find terms which are bigger terms. For instance, if I were to say to you, what will be the term in position 1000, for instance, just as an example. If you use this rule, then you can quickly find the term corresponding with position 1000. And what will be that term? You would simply take the constant difference, which is 5, and you multiply it by the position, which is 1000. So 5 times 1000 gives you 5000. And thereafter, you have to subtract 1. All right. So if you subtract 1 from 5,000, you'll be left with 4,999. So it means the term corresponding with position 1,000 will be 4,999. That will be the term. Can you see how quickly it is to find such a huge or bigger number or bigger position, which is now 1,000? So that is what we mean when we talk about the rule. Now, the following table has new patterns, and now I'm going to give you an opportunity now. I hope that the lesson was quite engaging or fruitful rather. I'm going to now give you the opportunity to use the same method to find the missing values in this table. You can see this is a new pattern altogether. And once more, the new pattern also has the constant difference. So first things first, you need to find the constant difference in the terms. Remember, in the terms, you need to tell me what is the constant difference. And so once you have a constant difference, then you can find the rule. And how do you find the rule? You multiply the constant difference by the position. And then you check if there's any number that you need to add to get to the term, or the corresponding term rather. So the first things, the first step will be to find the constant difference. So now my question to you is, what is the constant difference in these terms? You can see we've got the first term there, which is 3, followed by 6. The next term there is unknown, and then the other one is 12, and then the next one is unknown with 18, then unknown, then 99. But the positions, you have position 1, 2, 3, 4, and 5. Thereafter, you have the unknown position. Then you have 20, which is position 20 there. And then you also have the unknown position. So we have to now complete the table. First things first, what is the constant difference? Is there a constant difference? Yes, we are told there is a constant difference in this case. Before I can give you the constant difference, is there anyone who wants to attempt just to answer? Let me see if there are hands. So far, there are no hands. Even the chat, the group chat is quiet this morning. Rather, let me carry on. I'm just going to work it out for you once again. The term here, you can see we're moving from 3 to 6, and then we skip the next term there, and then we move to 12. But if you can look at our positions, you can see we have position 1, followed by position 2, 3, 4, and 5. You can see there's a pattern there. Now we have a pattern. So now that we have a pattern, you can see in position 4, the corresponding value there is 12. And of course, we can then find the constant difference. How do you find the constant difference? Obviously, you subtract the previous term from the current term. Yes, I see Junior already found the constant difference together with Huapili. You are correct. The constant difference is 3. The constant difference is 3. And then, of course, we are now going to use the constant difference to find the actual rule. Now, what will be the rule? The rule, you have to now multiply the position by the constant difference. So it means the rule will be, you take this constant difference and you multiply it by the position. So it will be 3 times 1. Can you see? So 3 times 1 is 3, and 3 is equal to 3. So it means you don't add anything there. You don't add or subtract any number there. Again, if you want to test with the second term there, the constant difference is 3. 3 times 2 is 6. And to get to 6, what do? Nothing, because you're already at 6. So what will be using the rule, so that it means that the rule now is you multiply the position by 3 and then you add nothing. That is the rule. So can you now find the missing term there? What will be the missing term there? What will be the term in position 3 using the rule? What will be the term in position 3 when we use the rule? I see that Huapili and Junior, you have given me the rule already. Junior, thank you very much indeed. So the term, according to Junior, and Angelina has found it as well, the term will be 9. And I hope that you have used the method that I've just taught you now by taking 3 and multiplying it by 3. So you multiply this 3 by the constant difference, which is 3. So 3 times 3 is 9. So now we have the position there. Position 3, the term is 9. And then you can see that you do the same with others. 3 times 4 is 12. So what will be the term now in position 5? Now that we have found the term in position 3. So Angelina Dube says that the term will be 15. Angelina is supported by Junior. Junior also says it is 15. And I cannot agree more. Huapili as well says 15. Yes, that will be 15. And how do we find the 15? By multiplying 5 by 3, the constant difference. So 3 times 5 is 15. Now, before we go to the 2 missing positions, can we find the position here? I mean, the term in position 20. Before we go to, all right, I see Junior has already found the missing position in the first instance. It says it's 6. Yes, I agree with you, Junior, that is correct. The next value there, it will be 6. Because remember, the constant difference is 3, and then if you take 3 and multiply it by 6, it will give you 18. So yes, 6 will be the correct answer. Junior found 6 together with Huapele. Huapele, I hope that I'm pronouncing your name correctly. Yes, you are also correct. 6 is the correct value there for the position. Now that we have found 6 as the correct position, can we now proceed to find the next term there in position 20? What will be the term? Thank you, Huapele. Junior has already found the term. He says the term will be 60. Together with Angelina as well, supports Junior, and Huapele as well says that it will be 60. And I hope if you can just type there, how did you find 60? How did you find 60? Just tell me, how did you find it? before we proceed to the next one, how did you find it? Okay, Junior says he multiplied 3 times 20. Yes, definitely that's correct. So you multiplied 3 by 20. Remember, the 3 is the constant difference. So yes, Angelina also agrees that you multiply 3 by 20 to get to 60. Yes, I agree with you. So 60 will be the correct value. Now, can you see now we have skipped the terms? We are now in term 99. And we want to know what is the position, in which position is the term 99. Can you see now that's where the rule comes in? It comes in because you can now use it to find the position. What will be the corresponding position to term 99? And this is the last question on this one. I just want you to work it out as well, and then we can look at whether you found the correct answer or not. What then will be the position in term 99? You can see this is a bit different because you don't just multiply by 3. But what I can tell you, the hint, is that you need to find a number. If you multiply that number by 3, then you must get 99. I see Angelina has already found the answer, and she says the answer is 33. Angelina, I fully agree with you. I fully agree with you that 33 will be the corresponding position of term 99. Reason being, all right, Angelina Dube found it correct there. Who else? Okay, yes. Huapele as well found that the correct answer is 33. And of course, I hope that you have you notice that if you multiply 33 by 3, you get 99. So definitely 33 will be the correct answer there. So as you can see, we have noted that at this point, it's very clear that position 3 has an output term of 9. All right. So how do we find that output? Because of the constant difference. In the same note, position 5 has an output term of 15. Remember, as always, the constant difference is 3. So you multiply the position with the constant difference. So as Angelina said, okay, Junior also found a different way of finding the position. He simply divided the term by 3. I agree with you. Also, Angelina, fully agree. 99 divided by 3 gives you 33, exactly. 99 divided by 3 gives you 33. So I hope that this lesson has been able to give you a clear picture of what to do whenever you are faced with the challenge of finding the rule. So now I'm giving you something different as a homework. I want you to take this table. You can see that we have some fractions in the terms there. I want you to write the 4th and the 5th term. You can see that we are given the first one here, 1, 2, and 3. So this is term 1, term 2, and term 3. So I want you to find term 4 and term 5. And then please use the rule to complete the table. In other words, you can find a term that is corresponding with position 30. This will be your. I see Junior already found the answer. He says that the next term will be 1/14. Yes, that's correct, Junior. But unfortunately, you will have to carry on with this in the as a homework. But you already have the correct answer there. 1/14 will be term 4. So term 4 will be 1/14. This lesson has now come to an end, and let me indicate as always that the lesson is brought to you by the STEM Digital School in partnership with Sasol Foundation. I wish you a good weekend until we meet again next week. Thank you very much indeed for taking the time and the trouble to participate in this lesson.